Hey everybody, it's Mr. Mott. What we're going to do is go over how to write names and formulas for ionic compounds that have something called a polyatomic ion. Polyatomic ions are groups of atoms that together have a charge, and we'll show you a bunch of examples of that, but we're going to treat them really in the same way. So I'm going to start out with some compounds that we've done before, which were just binary ionic compounds, so just two different ions. So if we start with our first example here on the left, we've got sodium chloride. So to be able to write the formula from that, we'd look at our ion sheet. And so we'd see that the sodium is the +1 ion, the chloride is the Cl- ion. And so we just need those charges to add up to 0, so we just need one of each. So my formula would be NaCl. All right. And when I write that, I don't have any charges on my compound. All right. Now we'll go to the right. In contrast, we have a compound sodium hydroxide. So again, we'd go to an ion sheet. We know the sodium ion is Na+. When we look up this word hydroxide, it's OH-. And so we treat them sort of in the same way. We need to have the charges cancel out. So if I have one of each of these ions, then the charges cancel out to make a neutral compound. So my formula is NaOH. All right. On the bottom left here, we'll go to calcium chloride. Again, we'll look up the ions. So we'd have Ca2+, and the chloride ion is Cl-. All right. We need the charges to cancel out. So we would have 2 of the chloride ions, giving us sort of a total charge of -2. Cancels out the calcium charge, so our formula would be CaCl2. Again, no charges there. All right. To the right here, we have similar compound, calcium hydroxide. So the calcium ion again is a 2+. The hydroxide from above was a 1-. Similarly to the calcium chloride, we need the charges to cancel. So we're going to have the OH- here. We're going to add a second one, so we have a total charge of -2. That's going to cancel out the +2 on the calcium. So we have CaOH2. Now, the tricky part of this really is that we need our formula to convey what we see. And right now it doesn't. So what we actually have to do is add a little bit of extra punctuation. We're going to add parentheses here. Sort of like in math class when you have a number outside the parentheses. In this case, we're saying we have 2 of the hydroxides, which is what we see, here. All right. So this is our formula to end with here. So CaOH2. All right, with parentheses. All right. Let's go to aluminum chloride here. Aluminum has a 3+ charge, and from above the chloride is a 1-. So we need a total of 3 chloride ions to make a neutral compound. So my formula would be AlCl3. All right. On the right, to the right there, we have something a little bit different. We have aluminum still, so that's a 3+. And we're going to look on our ion sheet for the nitrate ion, and that's going to be NO3-. Now, similar to what we saw before, the nitrate has a minus charge, as did the chloride. So we know we need a total of 3 of the negative pieces, which are the nitrates in this case. So we are going to have 3 of the nitrates total, NO3-, NO3-. So in total, we have 3 nitrates for every 1 aluminum. So we're going to write Al and then NO3. But similar to what we had above, we need parentheses around that nitrate when we say that we have 3 of them. So in essence, again, we're saying we have 3 of the nitrates. Okay? If I don't write it without it, and I write NO3-3, what it really looks like is that I have 33 oxygens, but we count them up. We don't. We have 3, 6, 9 oxygens. And then it also implies that we only have 1 nitrogen, and we have 1, 2, 3 nitrogen. So that's the reason that this is not correct. All right. let's take a look at a few more examples here. We have iron 3 oxide. The Roman numeral 3 tells me this is iron 3 plus. There's different charges with it. The oxide is O2 minus as the charge. And the little trick on this one, when you have an odd-even situation with the charges, we have a kind of a least common multiple of 6 between 3 and 2. So we need a total of positive 6. And we need a total of negative 6. So now we have the correct numbers or to cancel out our charges. So my final formula here would be Fe2O3. All right. Move this down for just a moment here. Okay. On the right, to the right there, we have aluminum carbonate. We have aluminum, which is a 3 plus, we know. The carbonate ion is something new. That's CO3 2 minus. Again, you would look at any of your ion sheets that are available and to find all these charges. So similar to what we had before, we had, a 3 and a 2 with the charges. The least common multiple is 6, so we need a total of positive 6. And we need a total of negative 6 by increasing our number of our carbonate ions, okay? Now, so this is my negative 6. So how do we write our formula? We have our 2 aluminum ions, and then we have our carbonate ions. And real important that 3 remains as part of the carbonate ion, all right? Now, we do need 3 of them total, so we're going to put parentheses around it anytime that we have more than one polyatomic ion. So our formula is going to be Al2CO33. All right. So now let's just work backwards a little bit on a couple examples. And I'm just going to scooch a few of these down. All right. So let's take a look. We're going to write our formulas for these next examples here. Again, you're going to have your ion sheet. And after a while, you're going to start to recognize a bunch of these. First part of our name is going to be the element name, and this is going to be calcium. And then the real clue that we have a polyatomic ion here is these parentheses that we see. And so we're going to look for the NO3 on our ion sheet, and we're going to see that it's nitrate. All right, and that was one example that we did above. Now, similar to when we named compounds before, the fact there's 2 in here does not appear anywhere in the name. All right. To the right here, again, we're going to start out with our element name, calcium. And then here, it can be a little bit tricky because there's not really an indication that we have a polyatomic ion because we don't have any parentheses. Something that's going to be helpful to recognize is that if we recognize that this first compound is a metal, which calcium is, then that's going to be the positive ion. Okay, so this is going to be kind of the positive ion. That means the rest of this is the negative ion. So we'd want to look for all of this as a group on our ion sheet. And when we find SO4, SO4 is going to be sulfate. So that's a little tricky because we don't have an indication with parentheses that this is a polyatomic ion. But when we're talking about ionic compounds, you're dealing with one positive ion and one negative ion. And that's going to be a helpful idea. All right. Similar to what we did here, similar to what we just did, going on to the bottom left, NaNO3. Symbol for Na is sodium. And then for, and so again, we want to be able to kind of split this. Sodium is our positive ion. The NO3 must be our negative ion. And so we're going to name this sodium, and then NO3 is nitrate. Okay. And our last one here, we've got Na again, which is sodium. And then we need to split this here. And And again, thinking about our sodium as our positive ion. And then we have the rest of this together as a group must be our negative ion. And the name of this guy is the acetate ion. All right. One example I just remembered that would be helpful to kind of go over is something like this. NH4NO3. Now, hopefully by now you recognize that we have this, the nitrate group, because we did a couple examples with that above. So if the nitrate group is the negative ion, okay, if this is the negative ion, all of this must be our positive ion. And it turns out we have the only positive polyatomic ion, which is the ammonium ion. So NH4 is the ammonium ion, and then NO3 again is the nitrate ion. Okay. If we were to look at and try to kind of go in the reverse there, if we had the name, let's say that we had the formula, and we'll do this over here maybe. Let's say that we had a name ammonium sulfide. All right. So looking on your ion sheet, we'd find ammonium as the NH4 plus ion, and the sulfide is S2 minus. All right. And so similar to before, again, we have to balance out our charges. We need a total of positive 2 to balance out the negative 2 from the sulfide. All right. So our formula here then would be NH4. And since we have more than one polyatomic ion, we're going to put parentheses, put a 2. And then we have S here. And that would be our formula for ammonium sulfide. All right. I hope that was helpful. Thanks for watching.